And the second review lesson on factoring is going to examine the other three types of factoring we should know from grade 10. I'll start with complex trinomials. Those are ones that involve three terms, of course, trinomial. But they have a number that's out front that cannot be common factored out. You can't divide 7 by 3. That's just not possible. Making fractions or decimals, and we don't want fractions or decimals. So the way most of us learn in grade 10 how to factor one of these things is something called decomposition. So we'll go through the first example while we're talking about the steps. Okay, so step 1 is multiply the first and third terms together. So 4 times 1 makes 4. Okay, we're now going to use the idea of man, or man pluses. You may have heard it. I need to think of things that multiply to this new number, 4. They have to add to the original middle term, also 4. What numbers do that? Well, 2 and 2 will do that. Okay, so step 3 says replace the middle term with the two terms. So our 4x squared is going to stay 4x squared. The middle term was 4x, but I'm going to replace my two new 2's. So 2x and a 2x. And my last term stays the same. So I've taken 4 and I've split it into two parts based on what these two numbers are. I can then use my idea of grouping, factoring by grouping. So we're going to split it in half, and we're going to common factor this half, 2x. And that was 2x plus 1. I'm going to common factor the next half. Now they don't have anything in common right now, but I have to take something out. So I'm going to take out a 1. Okay, little hint for you, whatever sign is here always goes down there, okay? What am I left with? Well, 2x plus 1. You know you're on the right track if your two brackets match. Your group matches, which of course in this case it does. So I'm left with a 2x plus 1 and a 2x plus 1. Okay. So the bracket that matched, and then the leftover stuff goes in the other bracket. Okay, let's try another one. Okay. First and last, my man has to multiply to 12, add to 13. Numbers that do that, 12 and 1. Replace. Okay, 13, I turned into these two things. Common factor. Take a 2x out, I'm left with an x plus 6. Okay, my sign gets carried down, nothing in common, so a 1. X plus 6. Hey, I'm on the right track, my brackets match. So my group and my leftover. Okay. We'll try one more just in case. And we should be okay with this method, I hope, by now. That's something we did last year, but if not, try the third one. Okay, 5 and 8 makes 40. Negative 22. What multiplies to those? I need a negative 20 and a negative 2. I always like to put my big term first. You don't have to. There's nothing wrong with putting it second, but I just put it first usually. Okay, split in half. And we'll be left with that piece. My sign comes down. It's a negative. And they're both divisible by 2 this time. And divide them out. And I have a common group, x minus 4. And I have some leftover stuff. Okay, complex trinomials. We like that method. It takes a little bit longer, extra, I don't know, 30 seconds, but it's a good method to be able to use to factor these things. Okay, next case. Look at some special cases. You might remember this idea of difference of squares. It's one of our special cases. It's a two-term expression. Okay. For this method to work, you have to be able to take the square root of both terms, and there has to be a minus sign separating the terms. If these two things aren't true, you can't factor it. Okay, the factored form will be the square root of the first thing minus the square root of the second thing times the square root of the first thing plus the square root of the second thing. And these are special things because they're really simple trinomials with a middle term of 0. So let's look at the first one. I wrote it in a trinomial form. Can you guys think of things that add to 0 and multiply to 4? The only ones that do that are 2 and 2, right? One's positive, one's negative. So x plus 2 and x minus 2. Or, if you think of this as a difference of squares, let's get rid of the 0 because it doesn't really mean anything. What am I left with? Two terms. I can square root x squared, that's an x and an x. I can square root 4, that's a 2 and a 2. and I put opposite signs between them. Okay, that's all that's really happening here. If we try the next one, x squared minus 0x, let's think of that as being gone. I got two terms. I got a minus sign. Can I square root x squared? Yes. Can I square root 36? Yes. Opposite signs between them. Now, what order you put your signs in doesn't matter as long as you have opposite signs. Okay, let's try the next one. I didn't put the 0 in this time. So we recognize the difference of squares. Two terms, minus sign in the middle, square root of x squared, square root of 100, opposite signs. It's done. We like difference of squares. They go really fast. A couple more for you. Okay, x square root of 400 is 20. Okay, try the next one. I got two terms. I got a minus sign. Square root of the first thing, 4x squared, would be 2x. Square root of 25 is 5. I get a plus and a minus. And try the third one, or sixth one, I guess. Two terms, minus sign in the middle. Square root. Square root. Square root of 64y squared would be 8y. 1 plus, 1 minus. Done. Okay. Second special case, if you will, perfect squares. A perfect square is a bracket that's the same thing twice. In fact, if we go back to the very beginning today, I gave you a perfect square already. This expression here is a perfect square. We usually write it as 2x plus 1 squared. Okay, now we can do it the way we did. We did it as a complex trinomial, worked perfectly fine. But there's a shortcut to it you might remember. Okay? To figure out if something's a perfect square, you have to be able to square root the first term and the last term. And then, here's the tricky part, the middle term has to be 2 times the square root of the first and the square root of the last. If that's true, it's a perfect square. So let's go check one we know is a perfect square already. The first one we did today. Okay, so if I look at this first one, can I square root 4x squared? Yes. Can I square root 1? Yes. If I take 2x times 1 and I double that, does it come out to here? It sure does, which means this is a perfect square. The way perfect squares work is you put a square on it, and you take your sign, and check out our answer. It's the same one we had down here, right? Okay, so it's a shortcut. So let's look at the first one. Now, if you don't recognize the shortcut, you want to do something simple or complex, totally fine. I'm just trying to show you a shortcut. Okay, can I square root x squared? Yes. Can I square root 16? Yes. X times 4 times 2 comes out to 8. Sure does. So I take the sign of the middle and I put a squared on it. Now, is that really any faster than doing man and saying x minus 4 times x minus 4? I don't know, but it's an option, right? All right, try the next one. Can I square root x squared? Yes. Square root 9? Yes. 2 times x times 3 makes 6x. Perfect. Plus squared. It's plus because of this one. Okay, try the next one. I can't square root 2. Can't be a perfect square. But everybody notice that they're all divisible by 2? There's a common factor here. Let's take that common factor out. And then see what we got left. Okay, I got a trinomial. Is it a perfect square? Let's give it a try. The 2's got to stay out front. Square root of x squared is x. Square root of 100 squared is 10y. 2 times x times 10y makes 20. Hey, it works. Sign squared. Make sure it's that sign. Okay. Let's try some more. Okay, I see. Can I square root 4x squared? Yep. Square root 9? Yep. 2x times 3 doubled makes 12. Perfect. Way faster than doing a complex one, right? Okay, last two. Can I square root 25? Yes. Can I square root 36? Yes. 5 times 6 times 2, that makes 60. Done. Really fast. And then the last one. Can I square root 16x4? I can. It's 4x squared. Can I square root 49y squared? Yes. 7y. 4 times 7 is 28. Doubled makes 56. Perfect. Done. Perfect squares. Okay, so again, today, review of some factoring. We're going to mix them all together tomorrow. I just need you to be able to recognize and know how to do the three today. Remind yourself of a complex, a perfect, and a difference. Okay, the homework you got was on yesterday's sheet. It's on the back side. Answers on the website. Answers